I'm Bjørn, the CEO of EcoCocon, and I'm here with our international sales and partner network manager, Paul Lynch.
Hi.
After a successful joint webinar with Jakob Strømann-Andersen from Henning Larsen, many of you sent great follow-up questions. We couldn't answer live. In this video, we will tackle them, hopefully straight to the point.
Yes. So we'll try to cover materials, finishes, building physics, structure, cost, beam, case studies, market access and collaboration through these questions. So I would say let's jump in and get some questions going. On the first topics we came across, it was the EcoCocon system. It was composition and finishes. So I'm just going to jump in now and give Bjørn the first question that you sent. Is there any binder or resins used in the straw panels, and are they made using compression? What is the density of the straw panels, etc., etc.?
So they are interested in getting to know a little bit more details about the panels. And in this case, we don't add anything to the panels or the straw for such. We in fact remove the dust, and so all we do is take the straw as it comes from the field, check it for moisture, press it in a kind of a mold, which I won't go into the details, and the density is around 115 kilograms per cubic meter. Yeah.
Very good.
So have you used any material other than clay for the inner surfaces of EcoCocon? For example, wood fiber based acoustic coatings, would that work? So what can we put on the inside? What do you think?
Yes, many other materials have been used than clay. Of course, when you go into high-rise buildings and big buildings, you won't be doing clay plasters. It's not cost efficient. It's not time efficient, which in many big structures, it's all about time of building. You can, most of the time, the most important thing is that everything is diffusion open. So we do woofy calculations on these different coatings that are used, and we figure out what the best types of materials are to use. This is a very important point.
So you can use more or less all kind of gypsum, plaster boards. I have seen three layer
wood, yes, which is used on the big project in Sweden. Yes, again, in principle, they are all usable, but we would like to make sure they are tested beforehand. So there's a woofy calculation done for this. And when we are sure about this, then it is safe to use these materials. Yeah.
More or less on the inside, it doesn't really matter what kind of material you use. You can use you should use a material that is safe as for resistance to fire, depending on what kind of resistance you need to achieve. So all our panels achieve without any surface at least Ray 45. So if you want more, you need to add something on top of it.
Exactly.
And we have different options there. So
precisely.
Just to fill in.
Okay. Second topic.
Yeah, that's a question for you, I think, isn't it? Because you are from Finland. And,
yes.
How do panels perform in terms of their thermal properties, especially in Scandinavian countries? Do they work in?
I'm
Finland?
As being based in the Finnish climate and working in the Scandinavian countries, yes, they perform really well with their thermal capacity, thermal properties. We are a certified passive house component build-up, and the thermal it has a U value of approximately 0.012, so we can achieve very high thermal properties. If it requires more U value or thermal, we can add a slightly thicker wood fiber board to the outside of the product to get to the higher values. We are building in 2 weeks' time in Kemijärvi, which is in the very, very north of Finland. So it's the highest, above the Arctic Circle that we've ever built. And this will be very interesting. And they are using a slightly thicker wood fibre board to keep the thermal properties of the products there. So yes, we can certainly build in Scandinavian countries, and we have done with many projects, including our tallest straw building, which is in Malmö in Sweden. So
yeah, great, perfect. So,
have you looked at ways to avoid plastic vapor air barriers using, e.g., using OSB or clay plasters instead? And what air tightness results do you achieve with this?
Yeah, that's definitely a topic for me. I'm a passive house specialist for years, and for me, air tightness is really important. We have developed a system with a membrane on the outside of the panels that enables us to achieve really good results with very little effort. Of course, you can do it differently. You can use the standard way of putting a airtight barrier on the inside. That doesn't do any harm as long as it's diffusion open on the outside.
Common in countries like France, etc.
Where they do have some regulations where it's necessary to do like this. Of course, you could use an OSB on the inside and tape it over. It's possible. In theory, clay plaster can be an airtight layer, only I wouldn't recommend it. We did 2 houses with it. It's just so much work to get it right. So this is not a cost-efficient solution. But all I'm saying is that there are so many ways of getting this right, and we are getting really good values for airtightness, usually already in the first test. So that shows that it's easy to apply.
Yes.
Okay, and then there is always this question about how does it deal with moisture? So do we check the moisture with inspection, digital monitoring, or what are the processes behind kind of?
Well, as Bjørn mentioned a little bit earlier, in the factory, we're already testing for moisture. In fact, when they come from the field, they're already tested for moisture. We store the straw in dry conditions. It's tested during production multiple times. It's tested before it's loaded onto the truck, before it's delivered to the customer, and we even send out documents with all of this information. And then it's up to the builders or the on-site project managers to keep testing it during installation, and generally after the clay plasters, etc., or other membranes or plasterboards are installed, it of course becomes harder to test, but you can still check the moisture readings within the rooms. But keeping a good moisture program in place, a good schedule for moisture test checking, it's actually low in most countries now. So
the most important thing for any house is to have a good roof and not have the panels getting wet. Of course, that's the most important thing, and the second important thing is to get the good air tightness so that you don't have any draft and condensation in the wall. If you take care of these 2 things, you won't have any problems with moisture.
Of course, it is one of the fears of building with a product, a biogenic product, or straw, or any other biogenic product. So keeping the professionalism around it, keeping the right way of building, not taking chances, not having any risks from the builders, having really good quality building, and having the right roof, foundation, etc. This is key, always. So
okay,
we're on to structural performance, timber loads. What is the maximum allowable stress or load for timber in the example of Bestseller, for instance?
Well, I'm not the engineer, but what I can tell you is that the high base were kind of self-load bearing walls, 10 panels high, so 30 meters high. So all the loads from their own weight were led into the foundation, and the metal structure behind it is just holding it in place, so for lateral forces, against lateral forces. So this is quite it's really a great example how like the load bearing structure can be kind of separated from the panels in a way where we can make the most out of our load bearing capacity. but for the main building, the terminal building, as we call it, we needed to use a different strategy. The floor heights are 7 meter high, and we needed to put some glulam in between our panels. Again, to our advantage, we have the possibility to adjust the panels to any kind of size, so we were able to really fit it into the design that was demanded by Henning Larsen, and we could take like the wind loads, which are really very high in that location. Yes, because it's close to the sea, and Netherlands, really high wind loads on these big facade areas. So the nice thing is that it's really easy to combine the materials with or our panels with other materials. Yeah, in our case, the panels are not load bearing in the sense that they carry any floors, but they carry themselves, or they are able to combine in the facade, provide a very good structural integrity.
And as you mentioned, it's the flexibility of our panels to be able to adapt to these different procedures or demands, and our engineering team being able to work with the local engineering team on such a big project to help this to allow this to come to a fold.
Yeah, very good. And then we have, of course, the
costs
the question about the costs and economics, exactly, and how do the capital costs compare, let's say, using EcoCocon and biogenic materials versus this typical shed, metal shed kind of structure you would otherwise use for a logistics center. So what do you think?
Well, we're never saying that we're the cheapest product on the market. So a lot of these transport logistics centers are built with SIPs, which is quite a cheap option. But we do have to keep in mind here that this was an environmental choice. It was an ethical choice to use EcoCocon in the Bestseller project. That is, and we also, I think what people don't take into account is we're not the construction company. We supply the product to the developers. And if you take a developer in a large project like this, the walls are about 16 to 20% of the overall cost of the building. So it's actually not the biggest cost of the building. It may seem like that when you're discussing it, but it's actually not. There are far greater costs than the wall sections. And so they took the step, for instance, in the logistics center of Bestseller to use a more biogenic and sustainable material than the regular SIPs.
Yeah. Maybe what we can compare is that, although it's definitely more expensive for the high base, because we're comparing a SIPs with a fairly complex facade construction. There are two different. It's quite big difference. But for the terminal building, where you would need anyway to fix a timber facade because that was prescribed by the architect, do everything. Any other solution would have cost you at least that much, I guess. So there we don't see that big a difference. No. And we have the advantage that we can do prefabrication, I think, really efficiently. So just to give you an idea, the logistics center went up like at the speed of about 800 square meters per week, which I think is quite comparable to other kind of industrial solutions here.
Actually, we've covered two questions in one here now.
We did. Okay, how good.
The construction cost.
We are efficient as well.
We're being efficient too. So design process and BIM. I'll leave this one over to you. How hard is it to prepare a project?
Well,
do you use BIM technology?
We always say it's really easy, but in the end, things become a bit more complex when you go into the details. And the nice thing is that we can plan it out up front, more or less exactly by the millimeter. So you need to invest more time into the planning, because what you design is what you get in the end. And it will be faster on the building site afterwards, but because all the preparation has been done before. So we in a way we don't use BIM in that sense. We have BIM models that might arrive on our desk, we transform it into parametric models, or parametric model of the panels that include all details and digital information, length of pieces of timber, amount of straw, and so on, which we then can use also in production. So yes, we do have building information methods which are connected from the 3D into production and also on site and logistics around it.
Yeah.
So I think we are quite far advanced in this level.
I think the next two questions go towards me then.
Yeah, that would definitely be it. Market, distribution, sales, and regions. What is the sales and distribution channel of EcoCocon products?
Well, we work with what we call technical sales consultants, who we find in each country. We have a lot of people who come to us, or we search them out. We have a tier structure in each country. We have some kind of very high productive countries, which we work with. We have more professional salespeople within those countries. But we generally like to work with everyone. We keep the doors open. We don't have exclusivity contracts with people. So we build on trust and ethics as well. We've been working with the same salespeople in most countries for over 10 years, some for longer. So we basically want to build. We are building a professional sales market.
Yeah, we are trying to take it from passion to professionalism, without losing the passion. I think that's, and I think we are quite good at getting that right.
So we are already sold to about 30 countries on 3 continents. So we have contacts in each country and people we work with, and we build up the way we work with them.
It's in fact a conscious strategy, because selling just in one market would be impossible. We need a certain volume of sales, so we are really represented in many countries so that we get the pilot projects going. Because it takes time for the architects to kind of learn and understand the system, get used to the idea that yes, you can build with straw, and then it's so much easier when you then later come into that country with a salesperson, or even with a factory or something like that.
Precisely. And just to keep in mind that one single host family project can take 2 years to come to fruition. So it takes time to build these things. It's not like you're selling pens or vacuum cleaners. It takes a long time to do.
Exactly. And here we come to the last question, which is quite, I think, good. We probably had some guy from Australia, because he's asking, can EcoCocon sell into Australia? So what is our answer?
We can, but at the moment we're concentrating on the markets we have and building those, really getting our case studies in, really getting to the core of how we can build.
So that's EU, and
we are in the US as well, in North America. We will be eventually looking towards that direction in the future, and there are some legislative barriers within Australia, in that they want you to fumigate any agricultural product that comes into the country, meaning chemicals, etc., which we're not too happy to put on our panels. But we have had a lot of contact from Australia, from architects, from designers who would like to bring our products there.
And it's not only Australia, we have really interest all over, which is really, a lot of interest out there, which we can't really
South America, New Zealand, Asia,
all over the place. All we can promise is that we will try to do as good as we can here in Europe first, setting up the next factory, hopefully in 2 years' time. 2-3 years time, and then at some point I guess we can export the technology to other places.
We have I mean the plan is to build everywhere and make this available to everyone, but step by step.
Great. Okay, I think we answered all the questions now.
We got to the bottom.
Okay. So I'm sure there are many more out there. So just
keep
the
sending us the questions.
Exactly.
We can keep answering them all the time.
Okay.
Nice to
See you next
all.
time.
Yeah, thanks a lot.
Bye.
Bye.